to talk about two things today, but they are extremely related that we're doing. And you've actually done the first one before, distributing. Okay, you've done distributing before. We did this before. Okay. Distributing, multiplying a term through all other terms. So distributing isn't that big a deal. It's not that new. Good. Okay, so on the first one, all right. So on the first one, you have two things that you need to worry about with your distributing. You're multiplying negative 5x times every term. Okay? So I do the first one. I have negative 5x times 2x squared. Multiply the numbers out in front, the way you multiply the numbers. So I have negative 5 times 2 gives me negative 10. And then x times x squared gives me x cubed. When you are multiplying, your variables can change powers. This relates back to the previous chapter. You're adding the exponents. You multiply the numbers, but you add the exponents. Negative 5 times 3x. Negative 5 times 3 gives me negative 15. X times x gives me x squared. It's not terribly difficult. Okay. And then negative 5x times negative 8. Well, negative 5 times negative 8 gives me plus 40. And then I have the x here. I don't have any other x's, but I still have that x to the 5x. I have to carry that through. Okay. It's not terribly difficult. We've done this before. The big twist on the distributing is now you're going to be dealing with powers of x increasing. Second one is still distributing. Just because it's in the back doesn't mean you don't distribute. I still have 5 times negative 2b and times 9. I just distribute going the other direction, but it's still the same idea. You're multiplying. You see anything stacked up to parentheses, it means multiplying. So I'm multiplying 5 times 9 minus 2b. Now I do 5 times 9, gives me 45. 5 times negative 2b, negative 10b. Like I said, it's not terribly difficult. We've done that, particularly the second one. Biggest twist is probably doing it in the other direction. But it doesn't matter whether the 5's in front or behind. You're still just multiplying. Questions on those first two examples? Okay, factoring. Oops. My bad. My bad. Yeah, no, everybody screws up every once in a while. Factoring. We're going to be doing lots of kinds of factoring. This one is pulling out the greatest common factor. This is actually the opposite of distributing. We're going to undistribute. That's the way I like to think about this. Okay. Our answers to these problems are going to look like the problems above. We're going the other direction. That's what we're doing. We're going to pull out the common thing that's shared. Now, there's two things I look at when I do this. I look at every term. I look for two things. First thing I look for, is there a number that divides into every number? So the first thing I do is I look at the 2 and the 12. Is there something that goes into both 2 and 12? And I want the largest number that divides into both 2 and 12. 2. 2 is my factor numerically. Okay. So my greatest common factor is 2 because 2 divides into both of those terms. I'm going to scroll this up. Okay. Then I look at the variables. Do I have a variable in every term? No, so I'm done. If I don't have a variable in every term, I cannot factor anything more than pull out the 2. This is my factor, but this greatest common factor, but this is only half my answer. Students often only give me half an answer. This is half of my answer. I can pull out 2. The other part of my answer is what's left behind when I take the 2 out. Okay, so I have 2y. I pull out the 2. What am I left with? I'm left with the y. Kind of makes sense. I have 2y. I pull out the 2. I'm left with y. It's things that are multiplying. Now I have the 12. I pull out 2 out of 12. I'm left with 6. Okay, because what do I multiply times 2 to get 12? I multiply 6. And these are easy to check your work. What do? You distribute. See if you got what you started with. That's how you check your work. Okay. So if I wanted to check my work, I just, 2 times y gives me 2y. 2 times 6 gives me 12. I got the same thing I started with. I did it right. If you want to do that. Next one, same idea. Look for my common factor first. I'll look numerically. I have 3 and I have 18. What's the largest number that goes into 3 and 18? 3. So my greatest common factor is going to include 3. Second question, do I have a variable in every term?
Yes.
Yes, I do. So now I'm going to pull a variable out. Here's the trick to pulling out a variable. Pull out the smallest exponent there is. So I have x squared, and then this is x to the first, right? So my smallest exponent is 1, so I pull out my x to the first. That's my common factor. I have a 3 in both of those terms. I have an x in both of those terms. Okay? So that's my common factor I pull out. Now, once I take the 3x out, what's left behind? I took the 3 out of here. It's gone. I had 2 x's. How many did I take away? 1. How many do I have left? 1. Minus. I had 18. I took out the 3. 18 times 3 is 6, so I'm left with the 6. Sorry, 6 times 8. 6 times 3 is 18. Thank you. Thank you for pointing out my mistakes while we're being recorded live for posterity.
You're welcome.
Now, how many x's did I have here? 1. How many did I pull out? 1. So do I have any left? No. I'm done. So when I look at my x's, when I look at variables, I say, okay, do I have 1 in each term? Yes. I pull out 1, and then I pull out the smallest power. Okay, that's factoring. That's pulling out a common factor. So, do the top problem. Distribute. Mm-hmm. Yeah. Oh, I am still recording. Okay. Not a big deal. Okay, shouldn't take that long to do one problem. So I distribute, which means I do negative x cubed times each one of those. So negative x cubed times 9x to the 4th. The negative and the 9 give me negative 9. And then I have x cubed times x to the 4th. I add the exponents to get x to the 7th. Okay. Negative x cubed times negative 2x cubed. Well, a negative times negative 2 gives me plus 2. 3 plus 3, x to the 6. Negative x cubed times 7. Yes.
I know it's smart. You don't have to remind me.
I generally think that smart followed by some body part is a little more appropriate.
Oh my god, it's calling me a smart ass.
Alex, I get that.
Okay. So distributing, factor, undistribute. Look for a common number. I want you to try to factor these. Look for a common number. Pull out a variable to go with it if there's a variable in every term. So give both of those a try. The second one, the number is a little more complicated. But go ahead and try factoring both of those. Look for the common factor. Go numerically first and then do the variable.
One's greatest common factor.
Okay. So the first one. Once again, I want to pull out a common factor. So I look at the numbers 5, 25, and 45. Largest number that pulls out is 5. And then I do have a variable in every term, so I pull out an x. And the smallest power is 1, so that's the power I pull out. So x, the first is what I pull out. Once again, this is half of my answer. I still need what's left behind. So I take 5x for 5x cubed. 5 is gone. I had 3 x's. I took out 1. I'm left with 2. 25x squared. I pull out a 5. When I take 5 out of the 25, I'm left with 5. I had 2 x's. I pulled out 1. I'm left with 1. 45. I pull out 1. I pull out the 5. That leaves me with 9. And then I had 1x. I pull out 1x. I don't have any x's left on my last term. Remember, there has to be 2 parts to it. What you pull out and what's left behind. Second one, 13 and 26. What can I pull out? 13. And here's a tip. 13 doesn't have any factors. I can't pull a 2 or a 3 or something out of 13. Does 13 go into 26? If 13 didn't go into 26, I may not have a number I can pull out. But that's one because you can check. It does work. I will pull out the 13. Now I do have a variable in each term, right? Pull out the smallest exponent, which is 3. Okay, I pull out an x cubed because I have my smallest power is cubed. So what's left behind? I had 13, pulled it out. I had 5 x's, pulled out 3. I'm left with 2. Okay. I had 26, pulled out 13.
What's next to the x? 13x.
X cubed. Okay. I had 26, pulled out 13. I'm left with 2. 2 times 13 is 26. Plus 2. I had 3 x's. I pulled out 3 of them, pulled out an x cubed. X squared plus 2 is what's left behind. By far and away, factoring is much more difficult than distributing, but it's just factoring in reverse. Okay, it's just factoring in reverse. Be careful with it. Don't rush. Once again, it's probably the more difficult part of what we're doing today. Any questions? Okay.